I have this coffee cup and I would like to know how much coffee can I put in it, right? So in other words, I want to know what is the volume of my coffee cup. We're going to set this problem up as a solid of revolution because we are practicing with those kinds of problems this week, and it's a nice application to sort of see what's going on, right? So the first thing that we want to do is figure out what kind of a curve I want to rotate in order to approximate my cup, right? So let's take some measurements. Okay, so let's take some measurements on my cup to see if we can figure out how to make some kind of an equation that will model what we're doing here, right? So the first thing that I maybe want to do is measure the diameter of the bottom of the cup, right? So if I look sort of at what the heck I'm doing here, it looks like the diameter of the bottom of the cup, the diameter of the bottom is around 6.5 centimeters. So its radius is around 3.25 centimeters. Okay, next thing that I probably want to do is measure the top of the cup, right? So I go ahead and measure the diameter of the top of the cup. So measuring diameter, looks like in this case I get that the diameter of the top is approximately 8.5 centimeters. So its radius is around 4.25 centimeters, right? So then the last thing that I probably need to know is how tall the cup is. So I go ahead and measure how tall the cup is, right? And I get that the height of the cup, up to about where I would try to put coffee in it anyway, is about 15 centimeters. So the height of my cup is about 15 centimeters. So if I draw a picture of my cup, looks something like this. So the height here, this dimension is 15 centimeters. The radius of the bottom is 3.25 centimeters, and the radius of the top is 4.25 centimeters. All right, now that I have all my measurements, I want to figure out what kind of a function that I can use with this data. So my idea is that probably the best thing is a straight line, right? The cup looks pretty straight on both sides, although if you actually sort of zoom in on what's going on here, right, you can see that there's just a little bit of space here in between the straight line and the cup. So this is only really an approximation, right? But we want to know approximately how much coffee can I fit in my cup. So we'll go ahead and approximate this as a line. So let's find the equation of the line and then go ahead and plot it. So the next thing that I want to do is try to approximate what is this line, right? So if I put some x and y axes here, this is the bottom of my cup, so I might as well put it on the x-axis, and I might as well put the middle of my cup through the y-axis. Okay, and so what I have here is that the height of this cup is 15 centimeters, so the y-coordinate of this point will be 15. Right, and the x-coordinate of this point will be the 4.25 because that's how far the radius is. So this point here is 4.25, 15. And this point here at the bottom is 3.25 and y equals 0 because I put the bottom of my cup on the axis, right? So let's take away the picture of my cup, right? And so what I want to focus on is just this line here, because if I rotate this around the y-axis, this line rotating is going to give me the cup that I want, right? So what I actually am looking at here is I have my x and y axes, and I have a line like this that goes through the point 3.25, 0 and the point 4.25, 15, right? So already I can tell that the slope of my line is 15, right? Because the slope is rise over run, and I go up 15, and I actually move over exactly 1 centimeter, right? So this is 15 over 1, or just 15. Right, and so then if I use the slope-intercept form, right, I have y is equal to mx plus b, and I know my slope now is 15, so I can plug in either of my 2 points here, right? So I can get 0 is equal to m is 15 times my x coordinate 3.25 plus b, and this gives me that my y-intercept for this function is negative 48.75, right? So the equation of this line is y is equal to 15x minus 48.75, right? So what I have is this equation of this line. I'm interested between these 2 points, and I'm going to rotate this guy around the y-axis. Next, let's actually rotate this line around the y-axis so that we can see the shape of the cup and figure out what the volume should be. So let's go ahead and find the volume of my cup. So when I do this rotation, I will have the sort of invisible other side of my cup here. And so the shape that I'm making with the rotation is these little discs, right? So what I want to know is, what is the volume of this little disc? And then I'm going to add all these discs up to get the volume of my cup, right? Well, the height of my disc here is just a little bit in the y direction, so we're going to go ahead and call the height dy, right? So then the other thing I need to know the volume of a disc is the radius of this. And so the radius of the disc comes from this x equals 0 all the way over to the line. So whatever this radius is, its distance is x. But because I have my height of the cylinder in terms of y, I'm also going to want to know what is the radius in terms of y. So radius is y equals 15x minus 48.75. Or now I solve this for x, and I end up with y plus 48.75 all over 15, or 1/15 times y plus 48.75, right? So this is the radius of my little disc in terms of y, right? So now I can go ahead and figure out what the volume of this thing should be. So the volume is, well, I'm going to integrate. And where am I going to integrate from? Well, the smallest y value that I have is 0, and the biggest y value that I have is 15. So I integrate from 0 to 15. The volume of all my little discs. Well, the volume of the disc is pi times the radius of the disc, which we just figured out, 1/15 times y plus 48.75 squared, radius squared, pi r squared, times the height, which is dy. Now, I just want to evaluate this integral, right? So I have a couple of constants that I can pull out. I have a pi, and then I have 15 squared. So it's pi over 15 squared times the integral from 0 to 15. Well, let's go ahead and actually also expand out this y plus 48.75 squared, right? I could do this by some u substitution, but for some reason I decided to expand, so let's go ahead and do that. That gives me y squared plus 97.5y plus 2,376.5625, and then this is dy. So I'm integrating, so I have pi over 15 squared times, I have 1/3 y cubed, I have 97.5 over 2 times y squared, and I have 2,376.5625 times y. And I'm evaluating this from 0 to 15, right? So I don't really care about x equals 0, because if I plug in y equals 0, because if I plug in y equals 0, I just get 0. So I just really care about what's happening at y equals 15, and so if I plug this all into my calculator, I get an approximate value of 666.6 cubic centimeters. So that's the volume of my cup in cubic centimeters. Great, so now we have an idea what the volume should be. But in the United States, most cups are not sold with a measurement of how many cubic centimeters of liquid they should hold. They're sold with a measurement of how many fluid ounces they should hold. So let's go ahead and convert the volume we found into fluid ounces. Okay, so I did my integration. I plugged in my values 15 and 0, and I got 666 cubic centimeters for the volume of my cup. But I want to compute the volume in fluid ounces instead of in cubic centimeters. And so I know that 1 fluid ounce is approximately 29.57 cubic centimeters, right? So cc shortened for cubic centimeters. So I divide 666.6 cubic centimeters divided by 29.57 cubic centimeters per fluid ounce to figure out how many fluid ounces I have. And I see that this is approximately 22.5 fluid ounces. So the volume of my cup in fluid ounces is approximately 22.5. My experience with this coffee cup tells me that I can fit about 16 ounces of coffee in it. So what's going on? Well, the first thing that we should notice is that what we actually got was just an approximation for the amount of coffee that we can fit in the cup. So we didn't get exactly the right amount. That doesn't really take care of all of the difference. So what is the other deal? Well, if I look really closely at my cup and what's going on here, this is actually what's referred to as a double-walled cup, right? So if I look, I can see that the rim of the cup is actually pretty thick, right? As I turn it, the inside of the cup is really a lot smaller than the outside of the cup. When I did all my measurements, I measured the outside of the cup. So I calculated the volume as if the cup had thin walls that don't really have any volume at all. But the volume of the inside of the cup is where I actually put my coffee. So while the cup measures well more than 16 ounces, I can only fit 16 ounces of coffee in it because that's the measurement of the inside volume. Hopefully you have learned something about solids of revolution as well as coffee cups in this video. If you have any questions, make sure to post on the forum. You could also try to find your own coffee cup and see if you can calculate the volume of coffee that you should be able to put in it. Good luck.